Okay, section 1.3, properties of numbers. And hey, I'm going to get rolling right away. There's a lot of properties here, just a lot of stuff here to deal with. So I'm going to get moving on this. And then we can answer any questions you have tomorrow. So properties of equality are first. Reflexive property, pretty simple one here. Any number equals itself. Just like, reflexive, your reflection in the mirror, that's what I always think of. It's you in there. On the other side, it looks exactly the same. So an example with numbers would be 9 equals 9. Symmetric property, you basically just flip-flop it. So if A equals B, then B equals A. You can write it both ways, and it becomes the same thing. So example using numbers, -7 equals X. Then you can write X equals -7. And it's the same thing either way, just the order was reversed. Transitive property. Transitive property can be a little tricky, but I like this one. If A equals B and B equals C, then A equals C. So it basically says if one thing equals a second thing, and that second thing equals a third thing, well then the first and third have to be equal, right? Because they both are equal to the second thing. So using numbers, I'll just give you an example of that. Let's say numbers and letters, I guess. If we have X equals 2Y, and we have 2Y equals 8, sure, I could figure out what Y was using algebra, but I could also use the transitive property and say, well, the first and the third thing have to be equal because they're both equal to 2Y, so then X is equal to 8. So I like to think of it as taking out the middleman. And the middleman in this case would be the B values here. Since they're both in, since B is in both the first and second expression, you take them out, and then you just have A equal to C. Okay, so that's the transitive property. And substitution, we've used that before, I think in the last lesson, and basically just substituting numbers in, replacing it with something, replacing one value with another. So think about like with substitute teacher. If I'm gone, you have a substitute, and they're going to teach you for the day. Obviously, they won't do as great a job as I do, but they're going to do the best they can for that day, and that's substitution. So we've dealt with that before. And so in this one, if we said to evaluate the expression, let's go with the one we used the other day, 2x squared, if X is equal to a -3. Okay? If that's the case, then you're just substituting in that -3 into the X, and then you actually do the math. So -3 squared, -3 times a -3 would be 9, and then we multiply by 2, and you should get an 18. That's the property of substitution, just replacing one value with another. Next up, I told you there's a lot of them, so we just have to deal with it. It's not the most fun section, but oh well, we'll just deal with it. Additive identity. So these are properties of addition, additive identity. So we've thought about, we've heard the phrase identity theft or stolen identity, and so one way to keep this straight is just say, if you add a 0, then you get to keep your identity. So it's kind of protecting you. You add 0, you keep your identity. So you take any number and add 0 to it, and it's going to stay the same. Like -2 in this case, plus 0, you get to keep your identity. In this case, the identity would be the number -2. Okay? Simple as that. Additive inverse along the same lines, only this time we're trying to get 0. We're trying to get an answer of 0. So if you add the additive inverse, then you get 0. So with this one, let's use like the number -3. So we want to get an answer of 0. So we want to have our answer be equal to 0 here. So if I have a -3, what can I add it to get 0? What can I add it to get 0? Well, in this case, I add a +3. And +3 would be my additive inverse, because it gives me an answer of 0. Gives me an answer of 0. All right, moving on down to properties of multiplication, the multiplicative identity. Kind of like the additive identity, you're trying to get the same number. You're trying to keep your identity. But with multiplication, but when you multiply by 1, you keep your identity. So again, sticking with that negative 2 example, negative 2 times 1 equals negative 2. And again, we're able to keep our identity because we're multiplying by 1. That old rule, anything times 1 is anything. And so that's called the multiplicative identity. The multiplicative property of 0. It just rolls off your tongue once you say it for a while. Say it 3 times fast. Multiplicative property of 0. Multiplicative property of 0. Multiplicative property of 0. And sure, you can change it to MPZ if you want to, if you're done with that lingo. So MPZ. And what does that say? That's a fancy way of saying anything you multiply by 0, you get 0. Anything times 0 is 0. So our example would be 3 times 0 equals 0. And that was one of the first things you learned as a young mather, was that anything times 0 is 0. Multiplicative inverse. I'm just going to give us a little more room here to work with. Multiplicative inverse. So another word that we're more familiar with might be the phrase reciprocal. The word reciprocal. That is the multiplicative inverse. It's the same thing. And what does it do? What does a reciprocal do? Well, when you multiply a number by the multiplicative inverse, or by the reciprocal, you get 1. So a couple examples of that. Let's say we had the fraction of 3 over 5. 3 over 5. And we want to get the answer of 1. It says you get 1 when you multiply it by its reciprocal, or by its multiplicative inverse. We want to get an answer of 1. So what would we do? What would we put here to multiply this by to get 1? Well, we would use the multiplicative inverse, or we'd use the reciprocal. So what's the reciprocal of 3/5? Well, we just flip this fraction over and make it 5 over 3. And then when we actually did the math here, across the top, 3 times 5 is 15. Across the bottom, 5 times 3 is 15. And you get equal to, which is basically equal to 1. 15 over 15 is 1. Okay? Another example, and we should do another one with just whole numbers, because sometimes we get a situation where we have a whole number and it's a little bit harder to think about the reciprocal or the multiplicative inverse. I'm using those words interchangeably. So if they said, let's use the number 2, and we want to find its reciprocal or find its multiplicative inverse to get 1. So again, we're looking at what is going to be right here. What is going to be your multiplicative inverse? So first we have to look at what is 2 as a fraction. Well, we just put a fraction bar and put a 1 underneath it, because 2 over 1 is 2. So now that makes our reciprocal nice and easy. We flip the numerator to denominator, and we get 1 over 2, 1/2. Now when we do the math here, 2 times 1 is 2 on the top. 2 times 1 on the bottom is 2. It would be 2 over 2, which is equal to 1. So again, anytime you multiply a number by its multiplicative inverse, you get 1 using the reciprocal. All right, so let's do some practice problems here. We can just do the first one. We can skip the second one, and you can come back and work on that on your own to help it. So we're going to evaluate this problem, but then we're going to name the property we use in each step. So we talked about this with order of operations, that I want you to show your work. I want you to show each step. And one of the reasons now is we're going to actually take that one step further, and you're going to actually have to name the property that you used. So we're going to do the work. Let's simplify each step by step. And then we're going to stop and pause and name the property we used. I know it takes longer. It forces you to stop and think. But that's what math is using your brain to think and analyze things. And so we're going to actually think about why we're doing certain steps and what we're doing. And it sounds a little monotonous, but it'll help you in the long run and later on in math. All right, so first, we're still going to use order of operations. So we're going to think about PEMDAS to solve this, to evaluate this. So the first thing we're going to look for are there any parentheses? Sure, right here, and then there's one right here. Okay, so if anyone's against doing both these parentheses at the same time, you should probably speak now. Okay, nobody there. So we're going to do both parentheses at the same time. And we can evaluate them just like we did yesterday in order of operations. So first parenthesis, 12 minus 8, 4. Should be simple. We'll move this down. And now I'm going to actually just bring down the 1/4, because that's the next thing we have to do. And over here, we've got 15 divided by 5 minus 2. Well, again, using order of operations within the parenthesis, 15 minus 5, or excuse me, 15 divided by 5 would be 3. And then we're subtracting 2. So 3 minus 2 would give us a 1 here. And then I'm going to bring down this plus sign. I'm also going to bring down this 3. So now we have 1/4 times 4 plus 3 times 1. So what property did we use there? Well, this one can get a little bit tricky because we were just doing the math. With the 12 minus 8, we were just subtracting to get 4, and we got a new number. And here we were dividing 15 by 5 and then subtracting 2. So it was actually just doing the calculations. Anytime you're just doing the calculations, we call that substitution. That's the substitution property. If there's nothing tricky, there's no zeros or ones that would be inverses or identities or anything like that, then it's just substitution. Okay, so now we have this problem, 1/4 times 4 plus 3 times 1. So again, order of operations tells us that we have to multiply first, and we got 2 different multiply problems here. So what I'm going to do is I'm just going to break it into each step. So first, I'm going to use this one here, 1/4 times 4. Well, what do we notice about this? Remember, if we had 4 over 1 here, that's a reciprocal. It's a multiplicative inverse. So those should equal 1. It should come down to be 1 here because of our multiplicative inverse property. And remember, if you just, over here, I'll do the math on the side. On the top, 4 times 1 would be 4. On the bottom, 4 times 1 would be 4, which is equal to 1. So what property was that? We just talked about it's the reciprocal, or you could say multiplicative inverse, or reciprocal. Either one works for me. Okay. With our second multiplication problem over here, 3 times 1. 3 times 1. Do we notice anything here? Well, 3 times 1, we know the answer is going to be 3. We know the answer is going to be 3. Sorry, this is a plus sign. Okay. But why did we get 3? Well, because anything times 1 is the anything. So 3 times 1, that is an identity. So we use multiplying by 1 is the multiplicative identity. So you can't just write MI because I wouldn't know the difference between identity or inverse. So you actually have to write it all the way out, multiplicative identity. And now finally, our last step is just 1 plus 3. And since there's no real tricky things with the 1 or the zeros or anything here, we're just adding these up to get 4. We're just actually doing the calculations 1 plus 3. Then that again would be substitution. There's no special property that goes with it. Okay? So I know you don't like to do this, and you can fly through it with your calculator. I understand that, but I'm going to ask you to do it, and we're going to stop, and we're going to think about what property we used to get each response. Okay? So we're going to skip step 2, or number 2, and we're going to move on to a couple more properties. These are our last 2 for the day. We've got commutative property and associative property, and they're not that bad once you can keep them straight. So the commutative property talks about you can change the order when you add or multiply. So you can change the order of the numbers when you add or multiply, and it won't make a difference. So with addition, if we take a 3 plus 2 or 2 plus 3, does it matter what the order is? In both cases, you're going to get an answer of 5. So you can change the order around with addition, and it doesn't make a difference. Same thing with multiplication. If you took 2 different numbers here, let's say 6 times 5, and we changed the order, 5 times 6, it doesn't really matter what order you put those in, 6 times 5 or 5 times 6, either way, you get 30. So you can change the order with the commutative property. Associative property says you can change the grouping when you add or multiply. So grouping, we're thinking parentheses. We can change the way things are grouped. So with addition, we can use, say, if we had 2 plus 3 plus 4, and let's say the parentheses were around the 2 and the 3. Then we have the same numbers, 2 plus 3 plus 4, but in this case, the parentheses around the 3 plus 4. Notice the order of the numbers hasn't changed. It's still from left to right, 2, 3, and 4 for both of them. Just the parentheses have changed. But does the answer change at all? Well, on the top one, 2 plus 3 is 5, plus 4 is 9. And the bottom one, 3 plus 4 is 7, plus 2 is 9, because you do the parentheses first. Didn't change the answer, didn't change the outcome, so that's called the associative property. You can change the parentheses. You can also do that with multiplication. So if we did, again, we'll just use 2, 3, and 4. 2 times 3 times 4, and use the parentheses here. Or 2 times 3 times 4, but use the parentheses around the 3 and the 4. It doesn't really matter. Doing the parentheses first, the top problem, 2 times 3 is 6, times 4 is 24. And the bottom problem, 3 times 4, using the parentheses first, is 12, times 2 is 24. So you can change the parentheses with addition and multiplication. Notice we didn't talk about division or subtraction. Those are a little bit different, and so we'll talk about those in class and why not we can't or can or can't use the commutative and associative properties. All right, so a practice problem down here. Evaluate 5 times 7 times 4 times 2. And I'm going to ask you to use no calculator here. No calculator. I know you can punch these numbers in the calculator and get the answer, but I want to see you use a property and then name the property you use. So hey, put that calculator away. I can see you back there. All right, so without a calculator, you could try to do this and say, okay, 5 times 7 is 35, but then you have to multiply that by 4. And then you have to take that answer and multiply it by 2. Could get a little confusing. But if we change the order here and just say, well, let's take 5 times 2, because everyone here knows that 5 times 2 equals 10. And then use the inside numbers as well, 7 times 4. Maybe not everybody knows, but we probably should know that this is 28. Now we've got an easier math problem, 28 times 10, which a little trick of the trade would just be 28 with an extra 0 on it because you're multiplying by 10. So what property did we use there? Well, we used the commutative property because we're changing the order of the numbers. It was 5 times 7 times 4 times 2. We decided to go 5 times 2 and 7 times 4. We'll get the same answer either way. So the first step we used was the commutative property. And then when we just got down here where it was 10 times 28, that was just substitution because we were just doing the actual calculation. All right, lesson summary. So all you have to do for the lesson summary in this box is state the difference between the multiplicative identity and the additive identity. There's a major difference between the two, just telling you what that is. And your practice problem here is evaluate this expression and state the property used with each step. So you're going to evaluate 3 minus 1 times 1/2. And I'm just going to tell you there's 2 steps. So you should have 2 steps to evaluate that, and you should list 2 properties with it. Okay? That's section 1.3, property of numbers. And bring any questions with you, and we'll go over it tomorrow when we get the chance. See you later.